Okay, we are now in progress. I'm going to go ahead and share my screen. Can you see the slide there, Zach?
Yes, sir.
All right, the thing that I want to emphasize here is what does the following mean? And you may have seen this before in previous presentations. If you have no clue as to what that is saying, consider yourself a normal person. However, this is where we're going to aspire to be able to have the capability of being able to interpret these complex pattern searches and what they're basically attempting to do. Having said that, there's a couple of things a couple of slides I want to mention is, as we know, SedCommand is a stream editor. And you'll notice that when we have had discussions before, the way you break down the synopsis of a Unix or Linux command is command name, options, expressions, or file names. Having said that, we have these options that are in square braces that are optional. And then we have the file name. Now we can, as we will see in certain examples, pipe output to the SedCommand to do specific things. Down here, the examples, excuse me, gives the 10,000 foot view. You can sed and use a one-line editing command against an input file. If we have multiple editing directives, we can have the -e option prefixing the two or more options, as well as being able to specify a script file name that has a set of sed directives to be able to do the necessary updates. Make sense?
Yes, sir.
Now, this slide here, and I'll get this to you because I put this together over the weekend. It's very similar to what you saw in my AUK handouts. We have data input that's coming into this pattern space, and the editing commands are going to determine how the data gets massaged, and then we have our standard output. Now, this is where it becomes interesting, where when you're new to SED, you can get tripped up. However, this four-step process is very simple. We read input line into the pattern space. We compare that line to the address space, pattern space, to see what editing commands apply. So compare the line address in the pattern space to the addresses on the editing commands. If the criteria is met, do the necessary editing. Now, there will be lines that do not satisfy the pattern space. So we will just basically read the input line into the pattern space and print it. I probably forgot a line there where I would basically print it. This will make sense in a moment, because what I'm now going to do is exit here. Where's PowerPoint? Close all windows, good. So now what I can do here is hit my screen. Oh. All right, so now we have this screen that's going to move over to here. If I can get it over to there. There we go. And then I will tell this to share. Okay, so right now you should see my one screen here with a set of commands, or basically my putty session. You see that?
Yes, sir.
One of the things that we do, and this is just a file called cars. And if you're not familiar with the NL, that's number lines. What that basically does, and I'll show this for example. If I cat cars, whoops, fat fingered it, I cat space cars, you can see the 10 lines. If I say NL cars, you can see how I now have each of those records numbered. Now that you see that, the examples that I'm going to have are going to make perfect sense. So here we do new line on cars. We can see the 10 lines. And what I'm going to basically this time around is pipe the output of the cars file that has the numbered lines to SED, and I'm going to delete lines 4 through 7. So that 4, 7 is start line. The second number after the comma is the stop line. So 4, 5, 6, and 7 will be deleted. I execute that command. You can see that we only have lines 1, 2, and 3, and 8, 9, and 10. Make sense?
Yes, sir.
So now, this is an attempt to go ahead and delete the records 2 through 4 and 7 through 9. I execute that command and I end up with an error because it's treating 7, 9D as some file to read. That's basically what the SED error message is saying. It says it can't read 7, 9D, no such file or directory. We have multiple entries there. And if you recall from the one slide, if you have multiple entries, you need to use the -E option. Here, I'm going to have number lines. Notice the -E, space 2, 4D, tac E, space 7, 9D. And there I am successful in being able to delete those records. Helpful?
Yes, sir.
This is primarily a good example of when you want to pull out specific lines. SED is probably better to work with in cutting and pasting specific lines as opposed to using the awk command, because it's a lot easier to be able to manipulate the line ranges. The comment may be asked, well, what if I have multiple lines? Well, that will be a perfect example of being able to use a script file with the -F option, which we'll see later of examples of how you can create a SED script file. Now here, I'm just basically showing us matching those lines that have an uppercase F or F, ORD, basically looking for the Fords that's in the cars file. And as you can see, I have Ford, lowercase F-150, uppercase F Ford Mustang, lowercase Ford Taurus. Now what I'm going to do here is for the Ford lines, those that match Ford, I want to print that. So as you can see in the SED command, enclosed in single quotes, I have FORD in lowercase, followed by the P, which says for that match, I want you to print that line. Now, what you'll notice here is we have a duplicate line of Ford. That's verifies and reinforces the fact that whether I have a match line or not, I'm going to output the data. If I massage the data, I'm going to output that as well. Now, there's a workaround that sometimes may work, and that is if I use the -N option, that says I only want the process lines to be outputted. I don't want any of the other lines. So you can see the Ford 150, Ford Mustang, Ford Taurus. What should happen here is I should only end up with two lines being Ford F-150 and Ford Taurus. And sure enough, that's what I get. Any questions?
No, sir.
Okay, again, we're displaying the 10 lines of the files. This time, what I want to do here is I'm going to do a sed where I'm going to substitute a 0 with nothing. So the first 0 that occurs will disappear. It will be replaced with a nil character. You with me on that?
Yes.
So as you can see here, 60 became 6, 10 became 1. You'll notice that F-150 became 15. You'll notice that there's still zeros on those lines, and we'll talk about how we take care of a global replacement shortly. Then we have the interesting aspect of I'm trying to figure out why. Oh, the reason why this one occurred the way it did, we had a 10, so that was getting rid of the line number of 10, and the 40 remained intact. This time, notice the G. That's basically saying for this expression, and this is what my substitution is, it's going to be done globally. As a result, you can see how we stripped out all the zeros. Helpful?
Yes, sir.
Oops. Now, we're going to match each line that is a Ford automobile. And this time, what I want you to notice here is here, we're going to show how we have a lowercase f, an uppercase f, and a lowercase f. So in this pattern match here, what I want to basically show you here is I'm correcting for those, and I'm going to pipe it to sed. Notice in this substitution replacement, this says find me F-O-R-D. Now go ahead and place it with uppercase letters Ford. And as you can see, the two that were lower cases were the ones that were substituted. This line here remained intact. Make sense?
Yes.
Now this time, notice the single character range. This is saying match an uppercase F or a lowercase f, followed by ORD, and we're going to the substitution string is going to be Ford. This time we will see nothing but uppercase 4. See the difference?
Yes.
Here we're going to take a look at cards, and now we're going to basically substitute the string Ford with Etzel in lowercase. So here we have Ford with Etzel, and as you can see, we have this in line 5 and line 7, which were lowercase Fords, line 5 and line 7. It was successfully replacing that with Etzel. Now we go ahead and substitute. We omit Kyle. Kyle, are you there? Let me check something here. Kyle, are you there? Can you hear me, Kyle? I think you're muted. I'll go back to the screen. So now here, as we're looking at this, we're now going to replace the uppercase forward with Etzel. So in that command line, notice how we spell it exactly as this, forward, which matches this. So this should become, when we are done executing, this will be done having Etzel in it. And sure enough, the other forwards were lowercase, they remain intact. Now, in this substitution, we're going to substitute uppercase forward with Etzel, and we're going to substitute lowercase forward with Etzel. So here we are with our output with the number line command operating on it. And now here we have substitute uppercase forward with Etzel, which will change this line. And then we have this substitution, which should modify lines 5 and line 7. Okay, Glenn screwed up. Any ideas where I screwed up?
Tag E, or yeah, you need a tag E.
Okay, need a tag E. So sure enough, notice the difference when I use the tag E, because I have multiple substitutions of pattern match replacement string. At that time, we get the desired results. Lines 5 and line 7 match this substitution. Line 6 matched from this substitution from what the original value was. Good stuff?
Yes, sir.
Now, this brings me to another good example. And I just want to show you this as far as we're going to replace a tab with a slash. And to understand this, let's take a look at the minus TVE. Are you familiar with TVE, Zach?
No.
Basically, the nice benefit of TVE, this is going to be printing tabs and end of lines in any non-printable character in the cars file. So if you take a look at that, you were seeing this file with spaces. Notice the up arrow I. These are tab characters.
Okay.
So that's basically the understanding of that. That's why notice the difference between the output here versus knowing that this was tabs. Now that you understand that this file is including tabs, you can see that now, and you have to take this on faith, what's in this particular, in between the two plus signs, is the tab character. And we're basically for lines 3 through 6, which will be Chev, and Ford, 3, 4, and I'm sorry, 3, 4, 5, and 6. 3, 4, 5, and 6. We're going to replace it with a slash. Now, the one thing I want to emphasize here, in the past, we were using either slashes or a colon. Notice here, we have the plus sign. The thing you need to remember is whenever you specify the substitute that you are going to perform a substitution, the first character immediately after the S indicating that we're doing a substitute directive becomes your field separator. You with me on that?
Yes.
We execute that command, as you can see, 3, 4, 5, and 6. The first occurrence of the tabs were replaced with a slash character. This leads us to the next example, as we saw the output, that this is a tab separated file. This time I'm going to use the tilde immediately after the substitution, saying this is my way I separate my source string of what I'm matching, which is a tab, and I'm replacing it. This time I'm using the G that allows me to do a global. That means all the tabs will be replaced with a slash. And sure enough, for lines 3, 4, 5, and 6, there are no white space that we see. All the tabs were replaced with a slash. Helpful?
Yes, sir.
Any questions so far?
No.
Kyle, are you still out there?
I'm here. I'm just keeping myself muted.
Okay, fair enough. Don't hesitate to ask any questions if you'd like to ask any questions, and welcome aboard.
No problem. Bedtime ran a little late for my kids, so I came in a little late. So I can't
Don't worry
exactly
about
start
that.
asking questions yet, but I'll catch up.
Not a problem. Now, this is the other area. We talked about using script files. So I'm just basically showing you the contents of this script file. So we have, it's basically saying lines 3, comma 7. So that's lines 3, 4, 5, 6, 7. Those lines will be deleted. So here we take a look at the cars file. Now you can see this time, instead of giving it a string or a command, everything is going to be read through the sed script. So sure enough, we said we wanted lines 3, comma 7 deleted, and they are not in that file. Kyle, you joined us a little bit later. I just want you to remember that NL space cars basically creates a line number generated file list. If I were to cat cars, just type in CAT space cars, all you would see is the manufacturer of the automobile first, followed by the next 4 columns. Now here's said script A. Now this is a mistake that I want to point out to you, Zach, as well as Kyle. This is a common mistake most people make when trying to insert or append lines. Here you'll see the 2I for 2I, and you have 9A for append. Remember, insert is going to be before that line. The append is after the number line that you specify. Now, the mistake here you're going to see is when we execute this command, it errors out. It says extra characters after command. And that is because it is a requirement that we're able to put in the backslash when we're doing insertions and appends. I don't know why you have to do that. I just know it works, and they tell you to do that when you take a look at any of the tutorials. So I guess I need to brush up on that. And
I have a question.
Go ahead.
The number and then the letter at the end of said script.
Mhm.
So can you go 1, 2, 3, or can you also go 1A, 1B, 1C?
Oh, just remember, these are just names of files.
Oh, okay. I
That's
thought we were
just
creating a script
these are
within the
just
program.
the names of the script files that I'm using. So here, this cat said script 2B is showing you the contents of said script 2B. You with me on that?
Okay, so it's not what I thought it was, and it can be anything you want to name it. Got it.
Yeah. So here again, 2I, just remember we have insert and we have append. So now what we're going to do here, after we take a look at the new line cars, this command here says I'm going to use the -F option, which says read the contents of said script 2B and make the necessary changes that satisfies whatever the matches are. And sure enough, if you remember, 2i. This line is inserted before line 2. Then we have 9a, append after line 9, and sure enough, it did that. Where this also becomes interesting is here's the sed script 3, and this is the contents of sed script 3. We've seen these entries before. Now what I'm going to do is delete line 5, and then I'm going to say 6 and 7, this text will be replaced. And there's a reason why I want to do this, because there's something that most people get tripped up with. Okay, do I have to worry about, I deleted a line, so is it going to preserve the line number, blah, blah, blah. So here we see cars. Now we see the sed script. Notice what happened here. We said we're going to delete line 5. Line 5 is gone. We said change. We did a 6,7c, which said this text replaced line 6,7. What this means to you and what you should be picking up is sed is going to basically index each and every one of the lines, and it's basically going to update those specific lines based upon the original text that it read in, knowing where these replacements need to be, because this was consistent in that we inserted it before line 2. So, some may argue that if we deleted line 5, basically you would have had after Plymouth, which is not the case. So it knows what all the original data space is and knows how to do the substitutions specific to those locations. Make sense?
Yes, sir.
All right. So this is where this becomes extremely powerful in that particular play. And as you can see, this will be extremely beneficial in learning how to update files, because the great power of using this -F option is you don't have to have long command lines. All you need is a file that has all your directives of how you want to massage data. Where this can work for you, because if you were to, Zach, let's say, become a field engineer, you may have to do some scrubbing of a log file that needs to be read, and you know what lines you want. And basically you can have in that sed script file the pattern matches to print those lines that match a specific phrase: warning, not enough space, error, could not process command. I'm just throwing that out as examples of how I have used this power to be able to parse log scripts that contain. I mean, one of the things that, if you haven't seen it, sometimes reading some of these log files for Apache are the biggest god-awful eyesores I've ever seen. It's just not fit for human consumption. So the one area too that you can do is when you look for those specific pattern matches, you might be able to also cut out, strip out specific data that's human readable, that would make more sense for management or someone troubleshooting a particular issue. Here, I just basically, we've seen these lines before. We have this line. I'm throwing this in here because basically I just wanted to know and emphasize that with a script file, we can have any type of combination of appending lines, inserting lines, changing lines of text, as well as doing substitutions. Now, what I want to point out here again, here's the S character. The character immediately after that is the colon. So we're using colon character to separate the matching string and the replacement string. In this example, we're using the tilde. Now, excuse me, let me get some water. So we're good on the cars file. Here's set script 4. Here's our insertion lines. Now, what I want to go back to, line 4 was Monza. And we said, if we find Monza, replace it with Impala. And sure enough, it was replaced with Impala. Now, this is a mistake that people can make. I said on line 3, substitute Chevette with Monte Carlo. Well, if we go back to line 3, in either case, we never had a Chevette listed, so no substitution will take place. The point of emphasis here is, there's nothing wrong to put in some type of substitution that may not exist. Basically, no harm, no foul. Basically, did it satisfy the pattern match? No, it just then gets ignored. And a lot of people do that in many types of parsing data log files.
Is there any way for it to bring back a response that will tell you that it had nothing to replace?
No, there is not, because the Streamline editor, and that's an excellent question, Kyle. The purpose of the Streamline editor is silently doing the text updates. There basically, if you wanted to say there was no updates, you would have to write some type of shell script for that. And we can show examples of that down the road. Okay?
Yes, thank you.
Oops. Interesting. All right, so I don't have a 08, okay. All right, so I'll go to 09. Okay, here we're going to cat numbers. And this goes back to what we discussed before when you saw that original piece of information. This looks extremely ugly. However, what I'm going to tell you here is notice this backslash open paren, backslash close paren. That's the first occurrence of a sequence of a backslash open paren, backslash close paren. This pattern match here is going to become positional parameter 1. Notice the backslash 1. Here, because a period in regular expression says match any character, the fact that I preceded it with a backslash took away the special interpretation. So it's saying, I want to match a period. This here is a span of characters. Now notice the syntax. Backslash open curly brace, backslash close curly brace. What this is saying is this period here can occur, since I have a 5 comma close curly brace, that can occur 5 or more times. If I had put in a value of 5 comma 10, then I would be saying it has to happen a minimum of 5 times, not to exceed 10 times. Now notice here, this is the second sequence of backslash open paren, backslash close paren. That becomes positional parameter 2. You will notice here, here's my forward slash that starts the delimitation of what my replacement string is. Here's the slash that closes that out. And here I have the substitution, which is positional parameter 1, followed by the hyphen character, followed by positional parameter 2. And then there's my forward slash to close out the syntax of my pattern match substitution string. So as you can see here, 5, because what we have here is we can have a digit 0 through 9, followed by a digit 0 through 9 that can occur 0 or more times. So 5, 10, and 15 match that. Then you'll notice here, I had 0 through 9, 0 through 9, which is basically saying I want 2 digits. This is why this line failed. So you can see this one didn't satisfy the pattern match because I was expecting at the tail end to have a minimum of 2 digits. Make sense?
Yes, sir.
So now this time, I'm going to use an asterisk. That is the regular expression that says match the previous expression 0 or more times. Now this is basically saying the second digit can occur 0 or more times. Here, this is saying the last digit can occur 0 or more times. Now this works in satisfying replacing all these periods that can occur 5 or more times with a dash. Now this may not be the proper way of doing things, because wouldn't it be better if I use the plus character? Because if you recall from when we did our presentation of the plus character, that says this 0 through 9 can occur 1 or more times. This fails. I can go ahead and have an asterisk there and do the plus sign here 1 or more times, and it fails. And I will venture to say that if you had a plus sign here and a plus sign there in both spots, it may not work. This is a bug with grep. I have argued this point with people in support for a period of 20 years, and they have yet to fix this. And to be quite honest with you, I doubt it will ever get fixed. However, this is where learning spanning of characters becomes important, because notice how I have this single character range of 0 through 9 listed once and listed once here. What's happening here is when we take a look at this whole expression, we are saying that we can have a digit 0 through 9 that can occur 1 or more times. And the same pattern match here. I can have a single digit, or I'm saying it will be a digit that can occur at a minimum 1 or more times. Make sense?
Yes, sir.
So now I go ahead and execute this command. You can see that I properly substituted all these periods with a single dash. This is a screwball example, but it shows you the power of substitute and replacement that exists with SED. We will be able to educate ourselves on more serious, more practical, real life examples of SED down the road. However, this is a great understanding and great sets of examples of how this gets manipulated to be successful. Now, there's another useful thing that I should point out. And I'm gonna use this as an example. I'm gonna cat numbers. Okay, so I'll do a clear screen, cat numbers. Oops. I fat fingered the cap locks. Now we see this. Now, what I want to mention here is I can say cat. And I'll go ahead and use this. I'm going to say, if I can remember this correctly, I'm going to say substitute. And I'm going to say /, and I'm going to do / open paren. And then I'm going to say 0 through 9. Close square brace. Then I'm going to say it can happen a minimum. Whoops, wrong side. 1. And it can happen 1 or more times. So now I use my closed curly brace. So now, after that, I'm going to close out my parentheses for positional parameter 1. Now I'm going to do a / period. Now I'm going to go ahead and say this period can occur 5 or more times. Then I'm going to set my second positional parameter. And then I'm going to say that can occur a minimum of 1 or more times. And I'm going to close that positional parameter out with the closed parenthesis. I'm going to do the /. And now I'm going to say I want positional parameter 1, followed by a hyphen, positional parameter 2. And then I'm going to close this out and close out with the single quote. Just for the heck of it, to demonstrate this, notice how that continues the continuation or causes the problem. If I were to bring this command back up, and then I have another common mistake that Glenn makes, put in the single quote, notice it complains because no such file or directory. Notice if I go ahead and now put in numbers, it properly does the stuff. Now I'm trying to remember why I'm getting no such file or directory. Oh, wait a minute here. Cat X09 .sh. Well, that works better. I don't know what I inserted it. So if I go in here,
I can tell you what you did.
what?
You put a 1 period / in your first parameter.
Ah, thank you. Okay,
Do you see it?
no, I don't. I got,
Go back to your first parameter right there.
oh, there it is. Okay, thank you. Okay, thank you.
I'm glad that happened because I was confused why it was like that and it was supposed to work.
Yeah. Well, that was a good catch, Kyle. So here you can see this. Now, one of the things I'm going to tell you is something that we used to do in years past. We have, this is Streamline Editor, and we'd have to redirect this to, let's say, numbers.new. Okay, because the point I'm making here is if I run this command, and if I go ahead and take a look at numbers, the file hasn't changed. You with me on that?
Yes.
So basically, that's one of the reasons why, as I said before, we go ahead and do this, redirect it to numbers. We go ahead and do a cat on numbers dot new. We can see we have the desired results. There's a new option that was introduced to Linux, and to be honest with you, I have no idea when the hell this happened. But what I'm going to do is I'm going to make a backup copy of numbers. I'm going to say copy numbers to numbers.bak, because we're going to need to go back to it shortly. But what I'm going to basically do here is say this time as you remember, when we run this command, numbers does not get changed. However, now, if I use a -I option, that is saying, I want you to directly edit that file. Because now when I run this and I cat numbers, it will have the desired results. So the -I option can be an extremely powerful tool to interactively edit files on demand with SED. However, this has a flaw to it. And the flaw very simply is, where's your backup file? Now, what most people would do, if I were to do a copy, I'm going to copy numbers back. So now I'm back to my original file. Okay, so we're good there. So now this time what I'm going to do is it can get monotonous to be copy this, now do the interactive editing. I mean, that's a good programming practice. However, the individual who provides you with this capability also, and probably before I do this, let's do a man on the SedCommand. And notice the options here. -I suffix. The suffix is not required. However, this is the key. Edit files, make backup if suffix is complied. Or I'm sorry, if the suffix is supplied. So what does that mean? This time, I'm going to append .bak. Well, actually, let's say that I already had that, so let's just say GMS. Now what I want you to see here is I'm going to say ls numbers and numbers .gms. Oh, I misspelled that, my bad. So they're there. So if I cat numbers, I have the modification. I cat numbers .gms, I have the original file. Good stuff.
Yes, sir.
So these are various features. And one of the things that also I should mention too is I'm going to just show you this. And this is where this becomes a good tutorial to figure out what you want to do. I have been in this industry for 35 years. So having been in this industry for 35 years, I do a lot of commands. And as you can see, I have these commands and I'm doing it with command options like I know the back of my hand. However, there are certain times you need to make decisions as to clarity. For example, I will ask you this question. If I do a man on sed, but before I do that, I'm going to say, what does the -E option do? Okay. How if I know? If we look at the man page, we see -E script. However, notice this. If you decide minus expression equals script, notice that that's more self-defining, and that will probably make sense to somebody as opposed to what the hell does the -E option mean? And the point I'm making is if I do something like this, I say sed dash dash expression equal sed script. One on cars. Whoops, what the heck happened there? I am going to try this real quick. That worked. Now what I want to find out, let's go back to the man page. Now I have to find out why that's not liking the interpretation of that file. Oh, I know what I did wrong. Excuse me. Here's the point of emphasis. That's the expression, and the expression equals the script. That's the actual substitution. What I should have been doing, and this is where people make mistakes. Don't get embarrassed if you make mistakes, because even I do it. What I meant to say is this. And sure enough, I got the desired results. Now, one of the things that I could do here to emphasize the script, let me do something here real quick. Let me find it. Come on, damn it. Okay, good. Okay, so that should be, let's see here. Good. So we're familiar with this, which allowed us to do the necessary changes. With the expression, the way that would work is you would have this to say, oops. So now we have the dash dash expression. So basically that in itself becomes more self-defining as opposed to having someone who could potentially scratch their head, okay, what the heck are you doing? And sure enough, it works. Good stuff. Any questions so far?
No, sir.
Okay. So one of the things that I can perhaps do is send you emails on this information so you can play around with it. This is really good way of good starting point of being able to how you can get to define some expressions. There's some other examples I can show. For example, let's see something here. I'm going to cats /Etsy/password. All right, so what I want to show here is notice that I have, this is the contents of the password file. Now notice that this is the user ID name. This is a placeholder of where the password string was kept years ago, but we now keep it in Etsy Shadow. This third field is the user ID number associated with GPatent. This is the group ID. This is the description field. Notice here I have a RNGD, that's a random number generator daemon that exists. Then after that, I have the home directory for the individual. And then I have bin KSH, which is the startup shell. So one of the things that you can basically do here, and I can show you this as far as this stuff. What I want to do here real quick is clear the screen, and I'm going to say sed, and I want to go ahead and say substitute, and we're going to substitute KSH with bash for /Etsy/password. And sure enough, you can see that. Now, again, do you recall, did I change the contents? Probably not, because I didn't do anything as far as using the -i option. That can be proven by tailing Etsy password, and we can see it still has KSH. So now what I'm going to do is the following. Here, when I run this command, I'm going to use the -I option. However, instead of doing something different, let's do this. Let's go back to the man page of SED. And notice here, in place. So with the in place, what I'm going to basically do here to in place, and I'm going to say .VAK, or I'll just say .GMS. And there's my substitution. Oops, I'm not sure what happened there. Oh. Here's why it failed. I forgot to use the equal sign. All right. Well, that failed only because I happen to be a regular user. However, if I did the following, where I prefix this with sudo, and now go ahead and put in my password. Oops. Now if I tail /Etsy password, you can see that these entries took place. If I go ahead and say tail /Etsy /password .gms, you can see that it has the original entries. That was a good summarization of some of the stuff to think about of how we can work effectively with SED. This pretty much concludes the presentation. Do we have any questions?
No, sir.
Kyle, you good?
Will this recording be available?
Yeah, I'm making a recording and I will, find a way to get that recording to you.
That would be great. Thank you.
Not a problem. All right, well, gentlemen, this concludes the presentation. Enjoy the rest of your evening.
How you
Thank
doing?
you. You too.
Thank you. Bye-bye.